As early as World War I, navies began looking at airplanes to hunt submarines. At the time, conventional land-based bombers, float planes, and large flying boats took on the sub-hunting role. They were only armed with standard high-explosive bombs. These really were not cut out for such a specialized job. Out over the open ocean, crews had to rely entirely on the naked eye to spot the enemy. Naturally, this kind of hunting only worked during the day in clear weather. Most importantly, the sub had to be caught right on the surface. Despite these severe limitations, British pilots repeatedly reported finding and destroying enemy U-boats throughout 1917 and 1918. Though, to be fair, those kill claims were rarely confirmed. During the interwar period, anti-submarine aviation got a highly effective new weapon, the depth charge. This finally made it possible to strike a sub that had already submerged and was trying to slip away. The problem, however, was that detection methods were still stuck in the pioneer days of flight. When World War II broke out, not a single country had fielded a dedicated anti-submarine aircraft. The leading naval powers just settled for hastily converting conventional bombers or flying boats for the job. Then, in the late 1930s, a true technological breakthrough came along. Radar. Radar finally gave aircrews the ability to spot and attack surface subs in any weather, day or night. However, early radar sets were incredibly heavy and bulky. They could only be fitted to multi-engine heavy aircraft flying exclusively from land bases. Engineers immediately started designing these types of planes, but once again, they were just modified heavy bombers. No matter how much fuel these flying giants carried, they still did not have the legs to patrol every strategically vital sector of the ocean. Great Britain suffered the most from this shortfall, as it critically relied on maritime supply lines. The United States felt it just as deeply. They had to haul massive amounts of military cargo across the Atlantic to build up forces in Europe. Land-based maritime patrol aircraft could only cover the convoys during the coastal legs of their journey. Once the transports pushed out into the open ocean, into the infamous mid-Atlantic gap, they had to rely entirely on their escort ships, and unfortunately, those escorts could not always handle the threat. Between 1940 and 1943, German U-boats sank over 1,000 Allied ships. This inflicted catastrophic losses. The situation demanded an immediate solution. What the Allies desperately needed was a compact anti-submarine aircraft. This plane had to be capable of operating from the decks of escort carriers. These smaller jeep carriers could sail directly with the convoys every step of the way. However, the ideal purpose-built aircraft for this job never actually materialized during the war. The Allies ultimately won the Battle of the Atlantic thanks to long-range, land-based patrol bombers. They also relied on a massive fleet of surface escorts like destroyers, destroyer escorts, and sub-chasers. If the Allies had possessed a proper carrier-based anti-submarine platform back then, victory would have come much sooner, with far fewer lives lost. Standard carrier aircraft like fighters, dive bombers, and torpedo planes still played a crucial part in the fight against the U-boats. But the lack of specialized onboard gear like surface search radar, magnetic anomaly detectors, or powerful searchlights often limited their effectiveness. Any attempt to cram that kind of heavy, specialized equipment into a relatively small carrier plane meant massively sacrificing fuel capacity and payload. This drastically reduced the aircraft time on station and combat effectiveness. Out of all the carrier aircraft in service with Western navies at the time, the most suitable candidate for the sub-hunting role turned out to be the Grumman TBF and TBM Avenger torpedo bomber. But even then, once you installed a heavy, high-powered surface search radar, there was barely any room left for weapons. The resulting payload was nowhere near enough to guarantee a kill on a tough enemy sub. To get around this limitation, the Navy decided to operate these aircraft in pairs. In this tandem setup, one Avenger carried the radar and focused entirely on tracking down the sub. Meanwhile, its wingman was armed with rockets and heavy depth charges. This second aircraft would move in for the kill once the target was acquired. This concept became known as the hunter-killer tactic. The United States Navy never got the chance to test this tactic in actual combat, but its flaws were immediately obvious. After all, a single tactical element now required two separate aircraft instead of one. Deck space on an aircraft carrier is always at an absolute premium. Because of this, finding the room to base a useful number of these pairs proved incredibly difficult. In the early post-war years, the backbone of carrier-based anti-submarine warfare relied on these hunter-killer pairs. This was true for both the United States and Great Britain simply because there were no better options. Grumman even developed a dedicated pair of aircraft specifically designed to work in tandem. This resulted in the AF Guardian. These aircraft did enter full-rate production. However, their operational careers ended up being pretty short, and they were quickly retired. Meanwhile, the realities of the Cold War were already setting in. An arms race was kicking into high gear. This time, it was between the former allies of World War II. Alarming intelligence began leaking out from behind the Iron Curtain. The Soviet Union was actively developing heavy submarines armed with nuclear cruise missiles. In response, Western nations pushed hard to field their own nuclear delivery systems. At the same time, they were overhauling their anti-submarine defenses. A top priority became fielding carrier-based aircraft. These needed to be capable of hunting down guided missile subs out in the open ocean. They had to stop them well before they could reach launch range of the coast. But when it came to tackling this challenge, the United States Navy and the Royal Navy went down completely different paths. The United States had a massive fleet of large deck aircraft carriers. These ships had incredibly spacious hangar bays. This allowed them to field the Grumman S-2 tracker. It was a massive twin-engine ASW aircraft, boasting a wingspan of nearly 70 feet. It was pretty clear that during its development, Grumman engineers were not constrained by any strict size or weight limitations. The British, however, faced a much tougher situation. Most of their carriers were significantly smaller than the American flat tops. Because of this, an aircraft the size of the tracker was completely out of the question. British designers faced a serious challenge. They had to engineer a much more compact and lightweight airframe. This new design still had to match its American counterpart in terms of combat capability. And how they managed to pull that off is exactly what we will be covering in this video. Back in late 1945, the British Royal Navy realized their Avengers just were not cutting it anymore. They needed something better for modern anti-submarine warfare. So they put together a new specification. It called for a modern carrier-based reconnaissance and anti-submarine aircraft. They sent this spec out to 3 major aviation companies that traditionally supplied the fleet. These were Blackburn, Fairey, and Shorts. This promising new project was given the code name Project Q. One of the key requirements was using the Armstrong Siddeley Mamba ASM-1 turboprop engine. The really unique thing about this engine was that it could run on marine diesel fuel, not just standard jet fuel. For a carrier-based aircraft, that was considered an incredibly valuable advantage. Since the war was over, designing and building the prototypes moved along at a fairly relaxed pace. Fairey was the first to get theirs built. On September 19, 1949, their prototype made its maiden flight. Test pilot Captain Slade was at the controls. A bit later, the Blackburn prototype made its first flight. And it was not until 1953 that the Shorts aircraft finally got off the ground. By that time, the Fairey design was already rolling off the assembly line as the Gannet. Things turned out quite differently for the competition. The Blackburn entry actually looked a lot like the Gannet. However, it never made it past the prototype stage. Meanwhile, the Shorts aircraft was named the Seamew. It ended up being a pretty awkward-looking two-seater. It had fixed landing gear, and its flight performance was straight out of the mid-1930s. Despite all that, British Naval Command were actually interested in the aircraft at first. This was because it was simple, easy to build, and cheap. In 1956, they even issued an order to adopt and mass-produce this flying anachronism. But later that same year, the order was canceled for good. The carrier-based Fairey Gannet, on the other hand, turned out to be an incredible success. The first prototype successfully completed its initial test flights, and in the spring of 1950, it made its first carrier landing on HMS Illustrious. Exactly 1 month later, flight testing began on the second prototype. After that, both aircraft were sent off for rigorous military testing. The final phase of carrier trials took place in 1952 aboard HMS Eagle. Naturally, during these test flights, the engineers kept a close eye on how the aircraft handled. They constantly tweaked the design to make it more stable and responsive in the air. For instance, they originally added aerodynamic wing fences, but later they ditched them in favor of 3 small auxiliary fins on the tail section. Meanwhile, Naval Command decided to make a major change to the original requirements. At first, the plan was to have a crew of just 2 people, a pilot and a navigator who was also supposed to double as the radio and radar operator. But they quickly realized that putting all that workload on one person was totally unrealistic. So the order came down to add a 3rd specialist to the crew. That is exactly how the Gannet evolved into a 3-seat aircraft. The engineers handled this surprisingly well. They quickly found room for a 3rd crew member inside the spacious fuselage of the aircraft. They managed to fit his cockpit perfectly right over the rear section of the weapons bay and the engine exhausts. The updated, now 3-seat prototype was ready to take to the skies in 1952. This aircraft became the baseline for full-scale production. Navy leadership was so impressed with the results, they immediately ordered nearly 200 Gannet AS-1s. The first production aircraft made its maiden flight in the early summer of 1953. At the controls was Peter Twiss, a legendary test pilot and holder of several world speed records. Less than a week later, the aircraft was presented to the public. This happened during a massive flyover celebrating the coronation of Queen Elizabeth II. Naval aviators were thrilled with their new sub-hunter. The aircraft proved incredibly reliable and extremely easy to fly. This was a critical trait for an airframe tasked with flying 5 to 6 hour maritime patrols over the open ocean. Unlike its predecessors, the new Gannet could not only track a submerged enemy, it could also engage and destroy it entirely on its own. Its arsenal was impressive. The weapons bay carried 3 250-pound depth charges or 2 torpedoes. On top of that, 16 to 24 3-inch unguided rockets could be mounted under the wings. This made the aircraft a deadly threat to any submarine of the era. Full-scale production spun up at several major aircraft plants. From there, the new aircraft went straight to Royal Navy combat squadrons. The first to receive the Gannet in early 1955 was a squadron deployed aboard the aircraft carrier HMS Eagle. Over its long service life, the Gannet saw action with 17 different British naval air squadrons. They flew from the decks of famous carriers like Eagle, Ark Royal, Centaur, Albion, and Bulwark. They also operated heavily out of land-based naval air stations. As soon as mass production began, Command started looking into a dedicated trainer variant. By 1954, this trainer, designated the T2, was ready. Externally, it looked virtually identical to its combat counterpart. The main difference was inside. The second cockpit housed an experienced instructor pilot instead of an observer. Their station featured a full set of dual controls and flight instruments. However, there was one major catch. The instructor had virtually zero forward visibility. To address this, a special periscope was installed right in front of the instructor canopy. In total, Fairey built 38 of these trainer Gannets, with a few even being exported. In the spring of 1956, brushing aside superstitions about the 13th of the month, the first Gannet AS-4 made its successful maiden flight. This new variant boasted significantly larger fuel capacity for extended missions. That same year, the upgraded aircraft entered full-scale production. Meanwhile, assembly of the older AS-1 was halted. By the end of the 1950s, the Royal Navy had added 81 of these aircraft to the fleet, along with 5 units of a new trainer variant designated the T5. The arrival of these modern sub-hunters was a massive capability upgrade for the fleet. With the new Gannets, the Navy was finally able to retire aging aircraft like the Avenger and Firefly. Simultaneously, they replaced early AS-1s that had already burned through their airframe hours during intense operations. In 1961, several Mark IV aircraft that had previously flown with the 831st Squadron went through an interesting conversion. They were transformed into dedicated electronic warfare platforms, receiving the designation ECM-6. Another 5 of these aircraft were rebuilt into cargo and passenger variants. Their new mission was the rapid delivery of VIP passengers and classified mail directly to carrier flight decks. To make room for this role, engineers completely removed the massive radar unit. They built a spacious cargo bay in its place. At the same time, they slightly lengthened the rear cockpit to make it a 2-seater. They also installed a couple of comfortable passenger seats inside. This transport modification became known as the COD-4. The anti-submarine Gannets had a surprisingly short career by modern standards. While crews were still just getting acquainted with these Pelicans, the United States and the Soviet Union were already launching their first nuclear-powered ballistic missile submarines. These cutting-edge boats could deliver devastating strikes right from the ocean depths. They could stay submerged for months at a time without ever surfacing. Against that kind of technology, the Gannet search equipment turned out to be completely obsolete. It was designed exclusively to hunt down older diesel-electric subs. On top of that, this coincided with the rapid decline of the British Empire. This inevitably led to massive budget cuts for the Royal Navy. As a result, the British Admiralty decided to shift its strategy. They pivoted towards smaller, more compact aircraft carriers. They planned to equip them with VTOL Harrier aircraft and various helicopters. All other development programs for conventional fixed-wing carrier aircraft were simply canceled. Around the same time, between 1958 and 1959, the squadrons flying the Gannets started being disbanded en masse. The primary anti-submarine warfare role was handed over to the new Whirlwind and Wessex helicopters. The decommissioned aircraft were sent off in droves to the boneyard. Eventually, they were just sold for scrap. The last to be disbanded was the 831st Squadron. They kept flying the AS-4 variants right up until the middle of 1966. The Gannet, like many other aircraft of its class from that era, does not exactly have an action-packed combat record. For the most part, throughout their long years of service, these aircraft never saw a major armed conflict. However, right at the start of their career, they did get a brief taste of action. In the fall of 1956, events unfolded in the eastern Mediterranean. Great Britain and France dubbed this Operation Musketeer. The Soviet Union denounced it as imperialist aggression against Egypt. Meanwhile, the rest of the world remembers it as the Suez Crisis. Egypt decided to nationalize the Suez Canal, which had previously been controlled by an Anglo-French company. The British and French responded instantly. They launched a massive airborne assault. In just 2 days of fierce fighting, they took control of the entire canal zone. Their triumph was short-lived, though. Soon after, under intense pressure from the UN, the Allies were forced to pull out of the area. Shortly before this military operation kicked off, British intelligence received an alarming report. Several Soviet submarines had arrived in Egypt. To neutralize this underwater threat, Command planned to deploy the ASW Gannets of the 812th Squadron. They were operating off the fleet carrier HMS Eagle. However, the panic turned out to be premature. It quickly became clear that Egypt simply had no one to operate the subs. The local crews had just started their lengthy training process. They had never actually gone out to sea in their lives. With the threat gone, the Gannets were temporarily sidelined. They were simply offloaded at a military base in Malta. In their place, the carrier took on Sea Venom fighter bombers, which were much better suited for the mission at hand. Later, in 1958, Gannets from the 847th Squadron were used for continuous patrols over the Mediterranean. They were based in Cyprus, which was still a British colony at the time. Their main job was to prevent Turkish and Greek ships from smuggling weapons and equipment to local rebels fighting against British rule. And honestly, that was about it. No other real combat operations ever appeared in the Gannet long service record. Interestingly enough, the aircraft was not known for high-profile crashes either. Throughout its entire service life, only 3 airframes were reportedly lost to accidents. Interestingly, aviation history remembers one incredible incident that perfectly illustrates just how rugged this airframe really was. During a live-fire rocket training exercise, a defective rocket exploded right under the wing of a Gannet before it even left the launch rail. The massive blast completely blew off the outer folding wing section along with the aileron. It also peppered the rest of the skin with shrapnel. Despite taking such critical damage, British pilot Eric Taylor demonstrated incredible airmanship. He managed to safely land his crippled aircraft. Afterward, the British heavily featured this dramatic incident in their promotional materials. This was to show the whole world the fantastic reliability and phenomenal survivability of their aircraft. Throughout its entire production run, 349 Gannets were built, including the early prototypes. Out of that total, 68 aircraft were exported. The lion's share went to Australia. The Royal Australian Navy had very close, long-standing ties with Great Britain. Just to give you an idea, every single Australian aircraft carrier had previously served in the Royal Navy. So it makes perfect sense that the aircraft sitting on their flight decks were also British-made. In 1955, Australia signed a deal to buy 36 Gannets. Out of those, 33 were the AS-1 anti-submarine variant, and 3 were the T-2 trainer modification. It is still a bit of a mystery why Australia needed such a large number of dedicated ASW aircraft. Back then, none of its neighbors were planning to attack. They did not even have submarine fleets of their own. Even so, these aircraft served peacefully and without incident down under. They flew right up until 1967, when they were finally replaced by newer Wessex anti-submarine helicopters. Later on, in 1959, Indonesia decided to buy a batch of 18 Gannets. They picked up 16 combat variants and 2 trainers. The Indonesian military operated them for a solid decade. However, since they did not have any aircraft carriers of their own, these carrier-borne aircraft had to operate exclusively from land. They flew out of Abdul Rahman Saleh Air Base. The third and ultimately final foreign customer for this British aircraft was West Germany. In 1960, the Germans took delivery of 15 AS-4 variants and a single T-5 trainer. They operated alongside the Seahawk fighters they had purchased shortly before. These became the first fixed-wing combat aircraft of the newly revived German Naval Aviation Branch. This branch had been dormant for 15 years. The brand-new Gannets joined the MFG-3 Graf Zeppelin Naval Air Wing. This wing was based in Schleswig-Holstein. Up until 1965, these aircraft flew regular patrol missions over the choppy waters of the Baltic and North Seas. Eventually, the decision was made to modernize the wing. It was then re-equipped with French twin-engine Atlantics. After that, the venerable Gannets were placed in reserve. They were finally retired from naval service for good in 1967. Today, at least 25 Gannets of various variants have survived in museums and private collections around the world. What is really cool is that at least 2 of them remain in fully airworthy condition and still take to the skies. Despite the major political crises and conflicts that shook the world throughout the 1950s and 1960s, the operational career of these aircraft ended on a remarkably peaceful note. They never had to drop live torpedoes or depth charges on actual enemy subs. Their radars never had to track inbound threats. They only ever locked onto training targets. And honestly, that is probably for the best. Now let us dive a bit deeper into the technical specs of the AS-1 and AS-4 Gannets. The British Fairey Gannet was an all-metal, mid-wing monoplane. It featured retractable tricycle landing gear and a massive turboprop engine. It had a crew of 3. This included a pilot, a navigator observer, and a radio operator who also handled the radar. The fuselage featured a semi-monocoque design with a stressed duralumin skin. The nose of the AS-1 variant housed an Armstrong Siddeley Double Mamba ASMD-3 turboprop. Essentially, this was a clever setup pairing 2 individual Mamba ASM-1 engines. They fed into a common gearbox. This drove a set of contra-rotating propellers measuring nearly 11 feet in diameter. This massive power plant produced a combined 3,035 shaft horsepower. Later on, the newer AS-4 variant received the upgraded, more powerful Double Mamba ASMD-7. The coolest and most unique feature of this setup was the ability to completely shut down one half of the engine during flight. The power from just one operating Mamba was more than enough to keep the aircraft cruising comfortably. This saved a ton of fuel during long over-water patrols. Looking at the internal layout, engineers placed the fuel tanks and a spacious weapons bay right in the center of the fuselage. The lower rear fuselage housed a retractable radar installation, neatly tucked away inside a composite radome. The wing design was also pretty unique. It consisted of a center section and outer panels that folded along 2 separate hinge lines using a powerful hydraulic system. This clever double-fold system was not just for show. It significantly reduced both the width and the overall height of the aircraft when stowed. Thanks to this trick, the rather bulky Gannet could easily squeeze into the cramped hangar decks of older British aircraft carriers. These carriers were originally designed for much smaller planes. When fully folded, the wings essentially formed a distinct Z shape. The wing geometry featured a distinct inverted gull shape. The intersections angled downward with a noticeable anhedral, while the outer panels pointed back up. This design choice, combined with the contra-rotating propellers, allowed engineers to keep the landing gear struts much shorter. It also provided a built-in advantage for a maritime patrol aircraft. If the crew ever had to ditch in the water, the lowest points of the wings would act like outrigger floats. This helped prevent the aircraft from rolling over or sinking too quickly. The tail section featured a unique triple fin layout. 2 auxiliary fins were mounted on the horizontal stabilizer. This stabilizer was attached right to the base of the main vertical tail. To improve stability and reduce the control workload for the pilots, the rudders were aerodynamically balanced and equipped with trim tabs. To carry out its primary mission, the aircraft was loaded with some serious search gear. This included a powerful Fairey ASV radar, along with an internal payload of 10 sonobuoys for hunting down submerged targets.